Welcome back to Workplace 30. We're moving on today to 1.2, which is titled The Equation of a Line. You can start by reading through the math on the job on page 27, and we're going to discuss the following three problems. So first, question number 1. Use the equation to make a table of values showing weights for ages between 2 and 5. So to make a table of values, that's a very nice straight line for us. We need to use the values of 2 to 5. So 2, 3, 4, and 5, and that would be our age. And our weight is determined by how old you are. Remember that this is for boys between age 2 and 5 years. Once you get to be an adult, it doesn't work the same way. But this is just the formula for this age category. So first, we're going to take the age 2 and plug it into your age. So we'll get 1.67 times 2 plus 9.67. And you'll go ahead and fill out the rest of the chart that way. So check your table of values on the board and you should have what I have there. Now, is this a direct linear relation? So remember that in order for it to be a direct linear relation, it needs to have a point that is on the origin or at 0 and 0. So what would happen if you plug in 0 for your age? You'd have weight equals 1.67 times 0 plus 9.67, which ends up being 9.67. In other words, we have a point that is at 0 and 9.67, which is not the origin, so no, it is not linear. Sorry, no, it is not direct linear relation. Okay, now what is the slope? So when we have a bunch of different points like we have here, to find the slope, we use the formula m equals y2 minus y1 over x2 minus x1. Okay, what is our y2 value? 14.68? Sure. So this could be our y2, our y1, and our x2 and our x1. So if we plug those in, we're going to get 14.68 minus 13.01 over 3 minus 2. And what does that give you? Good, it should give you 1.67 is your slope. Now, what do you notice about that number and our formula? So that number is the same as what the age is multiplied by. And that'll come into play later on. Okay, so there's many different ways that we can write slope. We know that we have this slope formula that we talked about just on the last slide. We also know that slope is the same as rise over run, and that slope is the change in y value over the change in x value. So notice that whenever you have a little triangle like that, that means change. Now the big formula that we're going to be using probably for the rest of the unit is y equals mx plus b. Now here, m is still our slope, b is our y-intercept. So if you have a graph, the y-intercept is the place that it crosses the y value, sorry, the y-axis, so this would be your b value. And then the y and the x would just be points that are on that line. Normally you don't have anything filled in for the y and the x, you'll plug something in for the m and the b. Now if you go back and look at the equation of a line that we were looking at before, this could be looked at as y equals mx plus b, and you'll notice that here m is your slope, just like we found out down here. Now your y-intercept would be 9.67. So you can see how that all works. So if you look at example 1 on page 30, we're going to start by graphing the data on the chart. Remember that your x would always be first and your y would be second, because your air temperature is dependent on how high above sea level you are. So you can go ahead and create that graph. All right, so once you're finished, your graph should look like this. Then we're going to move on to part B. Is the relationship between the elevation and air temperature linear? Is it a direct linear relation? So first off, is it linear? Yes, why? because it makes a straight line, good, and it goes up by constant amounts. Okay, so these go up by hundreds, these go up down, sorry, by 1. So, yes, because it makes a line. Okay, is it direct? Good, so yes, because it goes through 0 and 0. Okay, perfect. Then if we move on to part C, calculate the slope of the line. So we have a bunch of different ways that we can calculate this slope. We use our y1 minus y2 over x. Oops, it doesn't really matter if you go 2 or 1, as long as you're using the same on both top and bottom. So if we have this formula, now we can plug in 2 points. We could plug in the point 0 and 0 and the point -1 and 100. So we could have 0 minus a -1 over 0 minus 100, which gives us a +1 over -100, or in decimal form, a -0.01. And what are my units here? So degrees Celsius per meter, good, because your degrees Celsius is the y, or the run, and your meter is the x, or the, sorry, your degrees Celsius is the rise, and your meter is the run. Okay, then we're going to write an equation. So the equation should follow y equals mx plus b. We know that our slope is -0.01. We keep our x still in there. And what is our y-intercept of that graph? 0. Good, so +0. Really, we wouldn't have to even include this +0 because it doesn't change anything in our equation. So now we're going to use this equation to calculate the air temperature at the following elevations. So these are x values. So we're going to plug each of these numbers in for x and find y. I'll do the first one with you, and then you can try the next one on your own. So 239 we're going to plug in for x. So we get y equals -0.01 times 239. And your answer should end up being -2.39 degrees Celsius is the air temperature. Then try the next one on your own. All right, so the one that you're trying on your own, your answer should have been -5.2 degrees Celsius. Now the difference in this next one is that the degrees Celsius is actually our y variable. So we'll go -3.7 equals -0.01x. To get x by itself, we need to divide by -0.01 because that is the opposite of what is happening right now. So divide both sides by -0.01. And x should be 370 meters. So try the next one on your own. And your final answer should be x equals 680 meters. So if you got that, way to go. Now, mental math, make sure you're not using your calculators for this. If you have to drive 150 kilometers and your speed is 90 kilometers an hour, approximately how long will it take you to get there? I'll give you a moment to try that. All right, so there's a few different ways that you can go about doing this. You can either round the 90 kilometers up to 100, and then you can tell that 100 goes into 1050 10.5 times. So it would be about 10.5 hours. The other way you could do it is you could round this down to 990 and stick with your 90 because you know that 90 goes into 990 11 times. So if your answer was somewhere in here, that would be correct. Now you do have some homework for today, page 41, numbers 1 to 4. And yeah, that's homework for next class. I'll talk to you tomorrow.